Hey guys, Nick from Aguazio, here to show you the tutorial for serving pre-trained ML and DL models. We're going to run through it together, see what it looks like in Jupyter as well as the UI. If you'd like to follow along at home, go to the top of this page and click Download as a Jupyter Notebook. You can find this page on the left-hand side under Tutorials and Examples. I also want to note this great page in the docs called Tutorials and Examples, which has everything you need to get started. This includes the quick start, which I would start here, as well as individual tutorials for specific areas, including serving pre-trained ML and DL models. I also strongly recommend going through the rest of them if you find this helpful. So I've opened up the notebook here in Jupyter and we'll run through it together. I want to note that I will not be covering every single thing in the notebook, so I suggest you take a look at it yourself to get all the details. But I will be covering all the important parts. First thing we'll do after installing and importing MLRun is getting our project. We'll do this with mlrun.get or create project, passing in the name and a few parameters, which gives us our MLRun project object. We'll use this project to add functions to it and execute them later on. Now this tutorial will be using some of the built-in model serving classes in MLRun, specifically the scikit-learn model server and the TensorFlow Keras model server, but I did want to show all the options available at the time of this recording, and new ones are being added all the time. This tutorial supports both sklearn as well as Keras models, and you can change between the two by swapping framework here from sklearn to Keras. In this example, we'll be using sklearn, and this cell here just changes some of the parameters later on when we actually deploy the model server. If you're deploying sklearn, we'll be using the sklearn model server. We'll be pointing to an sklearn pickle file in S3, and we'll be using the standard MLRun/MLRun Docker image because this already contains sklearn. If you're deploying the Keras example, we'll be using the tf-keras model server, pointing to a Keras h5 file in S3, and using the MLRun/ML models Docker image. This includes some additional dependencies, including sklearn, Keras, and PyTorch. Additionally, we'll be setting a label which is specific to the tf-keras model server. But again, in this example, we will be using the sklearn model server. Next, regardless of which model server we choose, we'll be logging our model into the project using project.logModel and passing in the model path that we specified. This can also be done as part of your training job, but if you have a pre-trained model, you can do it like this. Then we'll create our MLRun serving function using mlrun.new function, passing in the Docker image that we specified, as well as the kind being serving. I also want to note you can install additional pip installs using this requirement syntax up here. Just specify them in a list. Then we will add our model to the serving function, pointing to the model that we just logged, specifying which serving class that we specified, either sklearn or the tf-keras model server, as well as this optional parameter called toList. And what this does is, if it's true, we'll return your predictions as a Python list instead of the default, which is a NumPy array. If you want to just return your response directly to the user, you should do it as a list. But if you need to do additional post-processing after your model's prediction, you might want to have toList equal to false. Then we'll print out the model server and take a look at what it looks like. In this case, it's very simple, but you can get a lot more advanced. This is an example of a much more complex model deployment, which includes steps for data enrichment, pre-processing, a model ensemble, as well as final post-processing. But really, you can do anything you want to do in real time, including data transformations, aggregations, and a lot more. You could read more about this under online serving pipelines. In order to test out our model server, we can create a mock server by using serving function.toMockServer to create the server. We can send things to it exactly like a model server, for example, getting which models are hosted at this particular endpoint, as well as sending test datasets to it and getting a response. Once you've decided that your model server behaves how you like, you can roll into the production deployment. The production deployment is super simple. We've seen it in a few different places up until this point, and that's done using project.deploy function, passing in your serving function. This will wrap everything up, deploy it as a microservice on Kubernetes, and expose it to an HTTP endpoint. From there, you can send things to it exactly like the mock server, except this is its own dedicated microservice running on the cluster. I'd like to quickly note that the model serving API is compliant with standards like Triton and KF Serving version 2. If you'd like to learn more about which routes are supported by the model server, go to this page in the docs. Up until now, we've been using the built-in MLRun model servers, but I do want to note it's possible to create your own. The way you would do that is by creating a Python class that subclasses the MLRun v2 model server, and then specifying a few of the methods. Specifically load, which is how you load your model into memory, and predict, which is how you predict with your model. There's a few other hooks you can specify like pre-process, post-process, and explain, but load and predict are the only two requirements. Once you have this in a Python file, you can then do the exact same thing we've been doing, such as creating an MLRun serving function with project.set function, passing in the name, the kind being serving, pointing to your Python file as well as your desired Docker image, and then adding your model to it with serving function.addModel, pointing to your desired model file, and specifically specifying the class name, which you'll note here is called classifier model, which matches up to the class that we created here. From there, the usage and deployment is exactly the same as the built-in model servers. If you're looking for more information on model serving, I recommend looking at this portion of the docs. It includes pages on using built-in model servers, building your own model servers, testing and deploying model servers, and more. So that's it for the Serving Pre-trained ML and DL Models tutorial. Thank you so much for watching till the end. If you found this helpful, I strongly recommend you check out the rest of the tutorials, which have their own dedicated pages as well as videos, as well as the Quick Start, which is a great way to get acquainted with what MLRun can do as a whole. So thank you so much. We'll see you in the next one.